Hello, everybody. Welcome, welcome. My name is Kevin McFall, and I'm very happy to be with you today in this Birds of a Feather discussion. I am a master instructor with NVIDIA's Deep Learning Institute, and it's a great pleasure to be with you today. I'm based out of Germany, and the department that I work with the Deep Learning Institute is responsible for all of Europe, Middle East, and Africa, which of course is all of you wonderful people out there. The topic of what we're going to be talking about today is how to bring AI and GPU accelerated computing to the classroom or to the universities. And so I've got some slides, I got some programs and stuff that we're doing at NVIDIA to talk about today. But I would just absolutely love for this to be an interactive session, to hear about what your journeys are, where you are at, and mainly would just love to help and support you all in the adventures that you are having with high performance computing, AI, accelerated computing, etc. So let me first go ahead and let you all know, apparently your webcams and microphones are able to be turned on and off. We're gonna have a reasonably small group today. So, I'm very happy for you to raise your hand or try to get attention and come on stage and talk. It doesn't have to be just me today. But maybe in the chat to start off with, maybe everybody can just say, introduce themselves, say what their name is, where they're from, and maybe what kind of position you have, because I'm really curious to know who my audience is, to know if you're faculty members, if you're graduate students, if you're working at a computing center. So maybe just in the chat, you can introduce yourself quickly and what your organization is so that we can all see. And I'm starting with myself here. Right. So we got Themba. There you go. Awesome. Who else do we have out there? Support scientist. Cool. I like that. I've not heard of that title before. Very nice. So who's the rest of us? Everybody's shy. I don't know. Is it lunchtime for y'all? See, you guys are 1 hour ahead of me, I think. I don't know. Can never keep it straight. But anyway, maybe I'll just break the ice and I'll start talking about some of the initiatives that NVIDIA has. And like I said, feel free to raise your hand, jump in. There we go. We got Marcus putting in a pyrometallurgist. Man, we got a lot of cool jobs here. Ferrochrome producer, very neat. Using researcher at heart. Very cool, very cool. So I'm sure we're going to have a lot of really interesting, wonderful people here today. Please do, I'm going to go ahead and start, put up my slides, but please, the rest of you, feel free to drop a little introduction in the chat and we'll all get to know each other. And I'll go ahead and get started, and please jump in if you got a question. This doesn't need to be a monologue, so if you got a question, please feel free to stop me. You can turn on your microphone and just say, hey, Kevin, I got a question or I got something to add. So let me go ahead and I'm going to share my screen here. And let's see. Let me pull up my slideshow. Just 1 second. I got all these screens in my way. I needed to move it away from the icon to get it started. Okay, so hopefully you all can see my screen. No, I just got rid of it. Boy, oh boy, gotta love it. I just tested this 2 seconds ago and it worked fine. All right, let's see. Can you all see my slides? Maybe somebody in the chat can say they can or can unmute them. Okay, got my slides. Awesome. Okay, so like I said, my name is Kevin McFall. I'm a master instructor at NVIDIA's Deep Learning Institute. I just actually celebrated my first year anniversary with NVIDIA, so I haven't been here very long. And in my previous life, I was a faculty member. I've been a faculty member before that for 20 some odd years. My background is all mechanical engineering, although my PhD dissertation, I worked in physics-informed neural networks. And since then, I've been doing a lot with computer vision, deep learning, robotics, mechatronics engineering. So I've been sort of all sorts of different things. But right now, I'm primarily focused in computer vision and other types of deep learning. And so I understand the pressures that faculty members are under in terms of having to develop their courses, run the research profile, run the research labs. So I know what it's like to face all of those many different responsibilities. And I'm really excited about what NVIDIA has to offer in terms of helping and helping to engage faculty and assist them in their teaching, assist them in their research, assist them in their professional development. So I'm going to be talking about a bunch of different programs that NVIDIA has that can help you. So here's just some information, sort of numbers about the Deep Learning Institute. We've trained over 300,000 people in our workshops and our courses. We have a teaching kit program, which is one of the main things I want to talk to you about. That's been downloaded over 14,000 times. We're in all over the world, 83 different countries, lots of different courses that we have available, lots of different programs. And so I just want to talk a little bit about them for you. We have a really rich content portfolio from very basic things like fundamentals of deep learning, fundamentals of data science, fundamentals of accelerated computing, and then courses and workshops in all sorts of different application areas, autonomous vehicles, graphics, conversational AI, healthcare, anomaly detection, all sorts of different things. Now, one of the questions I get asked a lot is, sort of what is in the Deep Learning Institute's business model in a way. We are not a nonprofit organization. Sort of what are we in this for? And actually, the Deep Learning Institute, our main key performance indicators are how many people we train in advanced technologies. And so it was a big step for me to move from working in academia to being at a private company. But the goals of what the Deep Learning Institute is about is to train more people and evangelize for AI. Now, of course, down the road, if people get hooked and are doing a lot of AI research, eventually they'll need some hardware, and hopefully they'll think about NVIDIA when they think about buying GPUs or other hardware. But what I have to offer is not a sales pitch. Everything that I'm going to show you is 100% free. Okay, all the materials that we have are free for you as university faculty. Okay. And actually, there's some opportunities for you to be paid through this. So I'm not trying to sell you anything. We really, myself included, are just really excited about helping people learn more about this technology and adopt it more in the work that they're doing. So again, everything that we're working on is completely free. So why is it a good idea to collaborate with NVIDIA on AI and high performance computing? I have been amazed at working at NVIDIA. There's so many amazing people doing work across every aspect of AI and high performance computing. It's amazing, all of the incredible work that's done at NVIDIA, and we like to share that. And we pull in real world examples. We have a lot of technical expertise at NVIDIA. There's some pieces that I'm going to talk about at the end of our NGC catalog, where we have all sorts of Docker containers that are managed with the best technology and the latest of every library, and they're all managed by us. And then all you have to do is, run a virtual machine in that Docker environment. So there's a lot of different things in terms of high tech that NVIDIA is staying on the leading edge of, that we can help plug you all into. Okay, there's just a lot of great opportunities. So specifically for educators, there's three main programs that I really want to highlight. There's a bunch of other programs and other links that are in this presentation. I did upload a PDF of the presentation to the conference website, so you should be able to download that, and it can be very useful because there's lots and lots of links in here. So if you can get yourself a copy of the presentation, you can follow through on all these links. But the three main programs that I want to talk to you about is faculty development workshops, opportunities for faculty to pick up new skills. Follow some of our workshops on anomaly detection or conversational AI or something that you want to broaden or deepen yourself into, okay? Then there's teaching kits. And these teaching kits, as you'll hear, are ways to help you develop new courses or to advance or improve your existing courses. And so there's lots of different materials in there to help you build new or existing courses. And then we have the DLI University Ambassador Program. And what that does is it gives an opportunity to certify you as a faculty member to teach our packaged workshops. So we have full day workshops that are already, the GPU resources are already available, all the materials are available, everything's ready to go, and we can get you certified to deliver them, and then you can teach them to anybody at your university, at any university actually. It can be to students, it can be to faculty, it can be at conferences like this. And so that's an opportunity through the University Ambassador Program. So there's a link here to a YouTube video that talks about some of the different things that NVIDIA is doing and how faculty members have been taking advantage of it. You can see we have just tons of different universities around the world that are working with the DLI and using our different programs. So the first piece I wanted to talk about is this faculty development. So say you want to learn more about, maybe you've done accelerated computing with CUDA, C and C++, but you haven't done that in Python. We've got a workshop for that. Maybe you're wanting to get more into accelerated data science, natural language processing. So here's a list of some of the upcoming workshops in the next couple months. And these are all free. They're full day workshops. I think some of them may be split 4 hours over 4 hours one day and 4 hours the next day. But it's a total of 8 hours. It's completely free as long as you're a university. As long as you're associated with the university, it's free. And there's the links there to register. So there's these workshops that we have, and just they roll throughout the year. And we have many different free options for you to learn more about some technology. So this is just a sampling. And like I said, as we go through the year, there'll be more opportunities for you to follow free workshops. So that's the faculty development piece, okay? Now, for those of you that are building courses having to do with this different technology, we have these teaching kits. And you can see there's 5 different teaching kits, from accelerated computing, or data science, which perhaps is the most attractive to you, but also deep learning, robotics, and graphics and Omniverse. And inside these teaching kits are a whole bunch of different things. There's syllabi and lecture slides and ebooks and videos and quizzes and assignments, hands-on labs, solutions to all these things. These were developed in coordination with the Deep Learning Institute, but they were actually the primary developers are other faculty members at universities around the world. So these are made by educators for educators with the input from NVIDIA, and then we just make it available to you. There's a couple pieces that I find really interesting here. Is these access to our library of self-paced courses. And so at the DLI, we have these instructor-led workshops, and we also have online self-paced courses. And anytime you download any of the teaching kits and use teaching kits, we will make available for free vouchers for your students to take any of these self-paced courses in our entire library. okay? And I forget, there's maybe 20 or so different courses, or more than 20, in our self-paced course library. So through the teaching kits, you can use these as an assignment, as a homework to the students. You can use it as a lab that they do, or it can just be sort of an independent study for them to work on these. So we get you, your students, free access to our self-paced courses. We also make available free vouchers for AWS credits. Okay, now our self-paced courses and our workshops, they use NVIDIA virtual machines on NVIDIA hardware run by us. But if you want to do something outside of the courses that we offer, say you have a project that you want to deliver and you don't have the computing resources on campus, you can request, and we're happy to get free AWS credits so that you can work in the cloud. So there's these hardware resources, there's the courses that we have available, as well as all these different lecture materials and all these different things. And so essentially, when you are approved to use one of the teaching kits, which basically is you're a faculty member and you teach in that area, that's all it takes to be approved for it, then you get access to all this material and you use it however works for you, whatever is useful. So if there's one of the laboratories that you really like, you can adopt that. If you like the lecture slides, you can adopt that. You can mix and match whatever is useful in this and fits into whatever course you're developing. So these are really great resources and can help if you're starting a new course in data science and you don't have a lot of material, it's a place to start. The robotics one, for example, we just updated that just came out last month. And so there's state-of-the-art things in each of these because they're updated frequently. So perhaps you've had a course in data science for some time, and you can go and look at, and maybe there's some fresh new material in there that could be useful for you. So you use it however you want. We're just happy to make all of that available, and whatever works for you, you use that. Okay. So here's just a little quote of somebody that we had from South Korea that was a teaching kit user, and they loved that there was the completion, that their students could complete those self-paced courses as part of it, and the content was really useful for them to help develop and improve the courses that they had. So that's really good to hear that people are making use of that. Now, the third main program that I want to talk about is our University Ambassador Program. And I mentioned that we have both the self-paced online courses as well as the instructor-led courses. And so those self-paced ones I mentioned before, they're available to your students for free as part of the teaching kits. Now, our instructor-led workshops can be made available for free to your students and anyone at your university or other universities when we can get you certified as a certified instructor for that workshop. And so we have many different workshops, like I was mentioning, the anomaly detection, predictive maintenance, all sorts of different ones, as well as fundamentals of deep learning, etc. So you would apply, for whichever workshop you're interested in. You go through a certification process, and once you're certified to teach that workshop, then you can deliver that to anyone in whatever format works for you. And so then you can, and again, as I was mentioning, that course is all packaged together. They're 8-hour-long workshops. They have GPU resources, so your students would just log in to the NVIDIA website, and they'd have access to spin up a virtual machine, and it runs with Jupyter notebooks. And there's all these hands-on activities, as well as lecture slides for you to present to them and teach them the theory material. And everything that we do at NVIDIA with the teaching kits, with the self-paced courses, and with the instructor-led workshops are really focused on hands-on activities. The code is there, students are working through the code, trying out different things, and it's a really good jumping off point that then students can go and then work on other projects, and they can copy and paste over the code snippets, and they sort of have a jump start for how to work with whichever technology they're working on. Within the University Ambassador Program, There is expense reimbursement if you go and travel to another university, say to present the workshop. You can get up to $500 US dollars reimbursed for the travel. We do have a new program that hasn't come out yet, hasn't been officially announced yet. But there will also be monetary awards for ambassadors who deliver multiple workshops in a 12-month period. So you can actually even get paid to deliver these workshops if you do enough of them. And there'll be more information coming about that. We'll probably launch in January is when we'll officially launch that, but that's coming. Also, as a university ambassador, there is an opportunity for you to also be paid to deliver these workshops to industry people. So there may be some companies, maybe small companies or anyone, startups or others in your area that are wanting to learn more about AI and high performance computing. Once you're certified in these workshops, then you can teach them to a paying audience where the industry would pay, and you pay. There's a flat fee to NVIDIA to deliver the workshop, and then whatever you make above that, you get to keep. So there's also opportunities there to earn money by teaching this to industry partners that you may have. So again, one of the big advantages to all of these programs is it connects you to me and others at the Deep Learning Institute, as well as other folks at NVIDIA, and all of the amazing work that's being done at the forefront of all of these technologies. So here's a quote from one of our university ambassadors in Italy. That they like the platform for introducing these topics to their students, and at least this person had a good experience engaging with the DLI team, myself and others. I think we got a great team, and we love working with all of our university ambassadors, and we're really excited about ramping up, having more of you in Africa. So we're really excited to do more across EMEA, Europe, Middle East, and Africa. Obviously, much of the activity is happening in Europe, and we would love to even that out where we've got tons of stuff going on here in Africa as well. So those are the three main programs I wanted to talk about, but there's a lot of other things here too. If you work with Jetson Nanos, if you do anything with robotics, we also have Jetson AI, Jetson Nano AI courses, as well as certifications. We also have several free courses. Perhaps this one here, an even easier introduction to CUDA, that actually runs in Google Colab, and it's completely free to everyone. It's a short course. It's not. It's supposed to, maybe I think it's supposed to be in 2 hours or something like that. Maybe it's even shorter. I can't remember. But it's a free course. So anybody that you're trying to get excited about, doing parallel computing or doing data frame operations or building a neural network, you can give them this link, and it opens up this Jupyter Notebook in the Google Colab environment, and they can run the code, they can see how things work, and get a really good idea about the basics of things. Okay. We also have another a longer course that is for universal scene description, which is for simulation, and even a free course for introduction to AI in the data center. So these are some free courses to everyone. Many of the things I've been talking about, the self-paced online courses and the University Ambassador Program, those things are specifically free for university folks like yourselves. But these ones I have listed are for everyone. So so there's sort of all levels. We also have we've published a book together with Pearson Education called Learning Deep Learning. So if you want to have a basic book in learning deep learning, we have that. I don't know how many of you have attended the GTC conferences, but that is really, really amazing. Have all of the leading technologists from all over the world come and speak at these conferences. There's a lot of great information there. And we just had one a few weeks ago, but never fear if you missed it, because this NVIDIA On Demand, you can watch all of the playbacks of the sessions from GTC. So that's a really great opportunity. Okay. They're also joining our NVIDIA developer program. That's how you get access to all of our software developer kits, like CUDA, like Rapids, like Triton Inference Server. So that's your sort of portal into all of the different SDKs that NVIDIA has to offer. And I mentioned earlier the NVIDIA NGC. And in the NVIDIA NGC, there are, I mentioned before, all of these different Docker containers. So say you want to do something in natural language processing, and it's such a pain to set up the environment and all the dependencies and making sure all of the libraries are compatible with each other. You just download a container for natural language processing, you open it up in Docker, and you're good to go. You've got a virtual machine with all the dependencies that you need. Okay, so not only in NGC are all these Docker containers for all sorts of different environments, but it also has a ton of pre-trained models and other Jupyter notebooks with lots of examples for how to do things. So that's a really great resource, and there's just so many different things that we make available for free to everyone, just so that they can work more with this technology. There's all sorts of other smaller programs that we have at NVIDIA, a hardware grant program, where if you don't have, you need more GPUs or other sort of accelerated hardware, you can apply for that grant program. I think the next window is opening in January to apply for that. I already mentioned some of these Jetson Nano programs. There's grant programs for that as well. We've got graduate fellowships. University recruiting. So if your students are looking for jobs as they graduate, we are always looking for very talented people. We have an Inception program that covers for startup companies. So if you have a startup company on the side, you can get into our Inception program, and that gives you access to a lot of NVIDIA technology and a lot of consulting opportunities with us. And just a ton of other programs directed towards higher education and research. So that's pretty much all that I had to talk about specifically. There are some other slides that come after this. There's sort of some additional information. But I wanted to just put out here all the different things that NVIDIA has to offer. And I want to take the time now to listen to you. Where are you in your journey with high performance computing and AI and data science? And are any of these things potentially useful for you? And maybe we can talk a little bit about what your situations are and how we might be able to plug in things to you. So I'm going to go ahead and end this, and we'll see how we can talk and see what all you guys are doing. All right. Anybody have any questions or want to discuss talk a little bit about what they're into? All right, we've got Jerusha, who's also a mechanical engineer, completed PhD 2 months ago. That's great. Okay. Anybody, what are you working on? Does any of this stuff sound useful to you? It's a tough crowd today, huh?
Well, Kevin.
I explained it so well that no one has any questions. Yeah, Kevin, go ahead.
Thanks. If I may just add, which I think might be interesting to the audience too, is what we're seeing here at the Center for High Performance Computing is that we have a small set of GPU nodes, but they're in very high demand.
Right.
They are NVIDIA V100s. We see them being used heavily by computational chemistry, so that's molecular dynamics codes, and of course machine learning, with machine learning being the fastest growing group at the moment.
Sure.
And so what we're seeing about the researchers who are approaching us, especially those who are supervising students and the students they're getting on board, is two complaints. The first one is lack of resources, i.e. access to GPUs. And then the second complaint is lack of knowledge, which is, I've got students, how do they get started? So I think that what you've broadly covered is actually answering those two questions quite well. And I would anticipate, I don't know what the other people in the audience feel, but I mean, those I think would be the two important conversations to have at the moment, at least amongst the people who are interacting with the CHPC. I don't know, there might be a lot of frustrated researchers and or students in universities that we're not hearing about. This is, where we need to start reaching out to them. But anyway, thank you. Let me hand over back to you and to the audience, please.
Well, great. Drew should just put a comment in the chat, and he's saying that he's feeling perhaps like what you're saying is, how do I get started? My programming skills are not top notch, and that's one of the great things about all of the content that we have is it goes across the whole spectrum. And that even easier introduction to CUDA, for example, that free course. The notebook is already built for you, and it has all of the code in it, and it explains all of the pieces in the code. So if you're not yet a really experienced Python programmer, you can still open up that notebook and see and look at the different pieces, and it can help you learn, all these different pieces. Okay, and so potentially how to use HPC for climate change adaptation. Right. And so do you have models that you're developing that you're wanting to accelerate, or are you trying to develop the models themselves right now? Sort of where's the bottleneck for you at this point in time? And you feel free to turn your microphone on and talk too. You don't have to only go in the chat. One thing I will mention is that there are a ton now of people like yourself who are not computer scientists, but are scientists, like the computational chemists and these others that don't have coding as their main focus, but they're starting to need more and more of those skills. We're actually developing a full day workshop, an 8-hour workshop for scientists and engineers to learn how to use high performance computing. So that is a big use case that's coming, and it's a workshop that we're currently developing, and I'm hoping in first quarter next year we'll have that one done. And that could be something that could be very useful to you and others of, how do you break into this space? I mean, Kevin was mentioning that too. I need to do more ML, or I need to accelerate things. My simulations are taking too long. How do I get started? And so a lot of the workshops we have, again, they're built on these Jupyter notebooks, and most all of the code is given there. And you don't have to be an expert at programming to be able to work through the workshop and be able to learn something and get examples. And I think that's one of the great strengths of the content that we have, is that it's very much practically based, and it gives you tons of examples about how to do different things, and to give you as a launching off point.
And I'll add to that, since the CHPC has worked with NVIDIA for a while now. So for example, at the last physical conference in 2019 held in Johannesburg, there was a one-day workshop on machine learning. So it was one of the DLI classes, and there were, I think, 3 instructors from NVIDIA. And it was a pretty good turnout. I think we had 24 participants.
Great.
And since then, we've had the GPU boot camp after last year's virtual conference. And this year, next week on Tuesday and Wednesday, we have the AI for Science Bootcamp online course.
Yeah.
Unfortunately, registration for that is already closed. We selected 55 people because that was the space we had, but we had nearly 100 candidates from South Africa, and then another 60 or so candidates from the rest of the world for that one, which I think is just an illustration of the interest. And so that's the kind of thing that the CHPC is pushing on. But we'd like to see a lot more initiative coming from the universities, as you call them, the ambassadors at the various universities, more integration in courses. Of course, we're very much aware, because we've been working for over a decade now on trying to get HPC in general in courses, that it's not too easy for lecturers to add to their syllabus without increasing the workload on themselves and the students.
Exactly.
So that's
it's a big barrier of entry, and
to try and get.
Indeed.
Yeah.
So that's one of the goals of the teaching kits, is to put that information
and yes, I
out
was just
there and
going to
ready.
say. So if there's less effort for the lecturers, they're more inclined to start. And particularly, I think those small, short courses you were talking about, the free ones and others that are self-paced.
Yes.
So students can manage it more within their own time.
Yes.
Than others. But going back to the specific comment in the audience about less programming experience, I want to just confirm what Kevin said about the fact that since you're working with Jupyter notebooks, you getting most of the code already there, and the only part you have to really modify is what's needed to understand that's the parts that are pertinent to doing the machine learning part. And secondly, because it's Python, it's a really easy language to pick up. And in that regard, I'll just point out that particularly for postgrad students in South Africa, the CHPC runs an annual summer school in January, and I believe applications are open for that, where we actually teach the introduction of Python to students in science and engineering. So these would be aimed at students who are just starting their postgraduate degrees, their masters usually, but also PhD students who don't have this background. And we realized we had to do that to prepare students for using high performance computing. And then I'll just add a last point, hopefully to encourage the audience also, is a big advantage of Python, apart from its ease of use, is it's a great language for helping you develop your workflow, your scientific workflow. It's a language that lets you take the output from one program, adapt it, and put it as input to another. And in, say, for example, the machine learning context, you can take the output from, say, a lot of your simulation codes, where you don't need to do any programming whatsoever. You're just running those simulation codes with different parameters and data sets. And then you can perform your machine learning model on top of those results to try improve your insight. Because, of course, there's that famous quote by Hemming: the purpose of computation is not numbers, it's insight. You're trying to understand your science. Yes, and I think that's what I like about the NVIDIA courses I've seen so far, is because so much of it, of the sort of housekeeping detail, has already been prepared for you in the Python Jupyter notebooks. You can focus on the important parts, really understanding what's going on, and you get a template for a starting point. You can take that code and try see if you can adapt it to your own. Start small. Anyway, I'll stop talking now. Hopefully, I've raised several points.
That's great.
And if the audience can at least share a little bit, I think very important to ask, what is sort of making people cautious about moving on to GPUs, or cautious about even starting these courses? Let's find out what are the barriers. Anyway, thanks.
Indeed, that's a very good question. What is it that's keeping you from making that next step forward with accelerated computing or AI or whatever machine learning that you're interested in? Yeah, what is it out there that's stopping you? Please share. Well, in any case, I put my email address there. So perhaps there's some people that are shy and not wanting to share with the whole group. But please, if you have any questions or want, yeah, here we got someone, please.
Hello, can you hear me?
Yes, absolutely.
Okay, thank you so much for the conversation. I am quite new to high performance computing, but computers has been my first love before mechanical engineering, in fact.
Cool.
However, I got drawn into engineering and thereby completing my degrees. What I focused on a lot is climate change. And I'm also very interested in NASA and what they do, NASA in America. So there's something that I heard.
I lost you.
Sorry, can you hear me? Can you hear me now,
I
Kevin?
can hear you. Yes, I can hear you, Jerusha. I don't know. Kevin might have lost his connection.
Is it my connection that's gone?
We can still hear you.
Oh, you can? Okay.
Yes. Okay. Sorry,
So
Jerusha, please. Yes, please carry on.
Yes, so I was saying that I'm very interested in what NASA is doing in the Earth Sciences mission. So what they're doing, I know that we are South Africa and everybody thinks developing countries, but I'm talking about the concept, right? The concept is that they are planning within the next 2 years from now till 2023 to launch about 6 satellites that will be specifically for monitoring the Earth. So not any other planet, but the Earth. And the purpose for monitoring the Earth would be just to be able to predict weather patterns in order to adapt for climate change. So not mitigate climate change, but adapt. So to see a flood, to see a volcano, to see certain natural disasters that are coming through in order to help people to move forward. So using that same concept in high performance computing, what can we do in a country like South Africa? Of course, we don't get volcanoes. We hardly ever I've hardly ever heard of an earthquake. But how does that concept now help us to solve societal problems? Many societal problems. So for me to speak about anything in respect to programming, the last time I did programming was Turbo Pascal. Way back.
I did that in high school too.
Yes. So I can't really talk to you on Python level. I've started a very introductory course just to familiarize myself with it. I do understand programming and I enjoy programming very much. So it's understanding the language, it's understanding how everything works together. So but I don't want to specialize in it. I sort of want to bring to the fore the potential that high performance computing has in all of in fact in all of life, in all of society. I think it doesn't get the attention and it doesn't get it doesn't get the attention because its potential is not well known, whether it is to businesses, whether it is to governments. It's not well known. And for me, I see the potential. And if whatever I have to do in the next 5 years or so with high performance computing and what I know, already know, is I hope to bring and to change that, together with other people, especially in the forums and in the universities. I think that it's quite inspiring to see. This is my first conference. It's my first touch point with high performance computing. I'm sure you can get that by me not talking so much about high performance computing itself specifically, but more interested in what can it do for the rest of South Africa. Yeah.
Well, I mean, one of the things you're mentioning is there's all of these satellites, all this new data, and when you have so much data, you need some sort of high performance computing to be able to crunch the numbers on it all. And with the newer AI models, they're able to do so much more than what they could before. And having the computing resources to work through that and being able to have large models, I mean neural networks, to be able to process them, we're able to do things that we haven't been able to before. NVIDIA has announced in GTC that they're trying to build the world's largest simulation of the Earth down to such a fine detail that they're able to do predictions and all of that. And it's only possible through high performance computing and AI. Now, what is really important, though, is that you're not a computer scientist. You have computing interest and you have some ability there, but you're not going to be able to program a million things backward and forward in 3,000 lines of code. Now, what's really nice is that the trend is heading in the direction that we need to make tools that are accessible to people like you. There's things like auto ML that will automatically try all these different hyperparameters and optimize your network. There's all of the frameworks, all the frameworks for doing machine learning. Yes, you have to write them in Python, but it's not like you're writing sorting algorithms and you're not writing the nitty-gritty details. You have like, here's my training data, and here's what I want my model to look like, and here is the goal that I want to have. Now go ahead and train it. It's a very high level, the types of programming that you have to do. I mean, when I did my PhD work in 2006 is when I graduated. I wrote everything by scratch. I mean, all of the whole neural network, because I was doing all this stuff with partial derivatives and I was having to do all these things, and it was crazy. I had to write everything from scratch, and it was extremely challenging from a programming perspective and time consuming. And nowadays, I was going back on some of the stuff I'd done in my PhD, and in a half hour, I could recreate that in TensorFlow because all of the stuff that I was trying to do that was so hard in programming, there existed a function for it, and I didn't have to do everything from scratch. And so it can seem daunting without having a computer science background, but so many of the tools are at a high level now that you don't have to do all this nitty-gritty programming. You don't have to program things from scratch. You just need to know how to fit the pieces together. Like Kevin was saying, of having somewhere to start and using it as a launching off point, and then taking what I learned in this little piece and then seeing, oh, there's a data set over here, I need to connect that in. And so the skills that you need to have now are combining pieces from different places and getting the interfaces to work between them, more so than actually programming the algorithms yourself. You don't have to do that anymore. So there's a lot of good news that for those of you that are not computer science as your primary focus, there's a lot of these tools being developed to help you be able to develop these things without all of that expertise. So I think if you can just get yourself in there and try some of these hands-on activities and try some of the coding, I think you'll see that it's not quite as daunting as what you might expect.
Thank you. Thank you so much, Kevin. And I do believe you. I do believe you. And I'm definitely going to dabble a bit in this, maybe even get a degree out of it.
Sure.
Now that I have my hands free, I'm getting a bit, I need something else to take, my attention and energy. And
Sure.
This is a worthy cause. I believe that it's a worthy cause and it has a lot of potential in it.
For sure.
Thank you so much for the information. I would be quite interested in the model of the Earth that you were talking about.
Yes, sure.
If we could engage maybe outside of this, that would be
Yes.
awesome.
My email is there in the chat. Send me an email and we'll continue offline, and I'll get you connected to some of the resources and things we're doing here at NVIDIA along those lines. It'd be great.
Perfect. Thanks, Kevin. Ciao.
Absolutely. Ciao. There we go. That was a good start. Are there any others out there that we can engage with and see if we can help jumpstart you into the future?
I had another.
Go ahead, Kevin.
Sorry. Yeah, I had another thought during your conversation with Jeruso, is that it's also a case we discover with our courses online, is that we have quite enthusiastic registrations initially. I mean, sometimes over 100 or almost 200, and then that tapers off very quickly. But I think that's a positive thing, because it means that people are prepared to try something new, even if they're not sure what it is. Because
Right.
I think one of the barriers, possibly, I mean, I was asking about what are the barriers, is people not knowing something that could benefit them. You know, the sort of known unknowns, or unknown unknowns. And
right.
It's a great
not even
way
knowing the questions to ask.
Yes, exactly. So it's a great way. I mean, I'm particularly going to mention those free, very short courses again. It's a great way to get started, and then you see the potential.
Right.
But you don't see the potential until you actually try something practically. And I think that's exactly the sentiment that was very positive from your conversation with Jerusha just now, is try something.
Yep.
Start small, even if it's, you know, something that looks just like a, I don't know, a toy problem or almost a hobby.
Indeed.
And especially based on your presentation, it's good to see that NVIDIA has a very broad range. And what we'd like to work towards, of course, well, at the CHPC is having more of those ambassadors, so that we get more of the well, not just the GPU, but the more practical teaching out there in the universities.
Yes. Agreed.
But anyway, once again, I'll stop talking and ask the audience if they feel like contributing, asking a question, or making a comment, or even making a complaint. I mean, complaints are also opportunities.
What's NVIDIA doing here? They're just trying to sell more GPUs, right? But please, if you are shy, take down my email address and email me. Go and get that PDF file and download it and explore those links, and let me know if you have any questions.
Hi, Kevin. How are you?
Doing great. Happy. How are you?
I'm good. Yeah, no, I've been listening to your talk. I got in a little bit late because I was jumping from another talk. But
sure.
I think I share the sentiments of is that Jerusha. So when I got in, she was commenting about the importance of high performance computing and all those things. So I think I really agree with her point. And the main reason and our objective is to make sure that we can be able to accelerate all those important applications.
Yes.
Looking at the applications in those areas, Jerusha, like for an example, your climate modeling, those are some of the big users of high performance computing in the country. And you're looking at things like large simulations in bioinformatics, so genomic sequencing. It's other areas, for an example, also on engineering simulations to make sure that we can be able to do
Yes.
large refined models that represent close to reality, because in that way, then we can be able to build digital twins. So
Yes.
it's the whole objective, and I think you are spot on in terms of what we want to show as a return on investment for high performance computing. And in the past, we were struggling to be able to show that the return on investment. But today, and the reason it was because it was only the select few applications, and mainly in the engineering and the sciences. But this has gone now to things that every person on the street can relate to. Like, for an example, weather, you look at things like now, big data analytics, which goes into all the areas. It goes into making decisions in retail. It goes into even how you organize your life, because now with everything, with Internet of Things,
Yes.
everything at the edge. So it needs us to be able to get the processing now for everything. Basically, when you walk around in the mall, there is all this data
Everywhere.
the things that people will know what item you are going to pick up from the shelf,
Yes.
or when you walk into the store. So and then that helps the retailers to be able to plan properly for customers, so things becomes much easier. So high performance computing is not only for elite few domain in science and engineering. Now it's for everybody. And
Yes.
yeah.
Absolutely. And you're absolutely right. It is for everybody, because we're showing that in every industry, in every field, you can see that return on investment. You can do more with all of this data. And I really like your point about the simulation and the digital twins, because that is really coming. And again, in all sorts of different fields. One of the teaching kits is dedicated to that simulation and Omniverse. We have a self-paced course on that too. And we're realizing that we can simulate the entire world now with the computing power we have. But even like, companies like Siemens are doing simulations of their equipment to be able to predict when things are going to fail, when their equipment's going to fail. They're digital twins of factories to be able to optimize manufacturing processes. And so this idea about digital twins and being able to design things in a photorealistic environment and test it out and try your design in the virtual world before you go and build it in the real world has so many benefits in terms of time to market, cost, the development cost, all of that sort of thing. So yeah, I see what you're talking about is very relevant for today's time.
Yeah, now I'm glad you raised the example of Siemens, because I remember when Yael was putting her, her material for the virtual booth.
Yeah.
I saw that she did not include that example.
Okay.
And it is so true for South Africa, because it talks about Siemens looking at the power plants and looking at the proactive maintenance programs.
Yes.
So basically looking at how building the digital twins of the power plants help the power producers to be able to understand when things will fail and where are they going to fail. So
exactly.
the active maintenance is done even before those things are happening. So if you look at the reality of where we are in South Africa, and we have been having like some load shedding, and the main thing was that things were breaking, and it was not predetermined whether something is going to break. So basically, we were just fighting felt fires all over the country in the power plant. So I looked at that, and it was really a very good example of something that we really need to have. But you know, the belief in digital twins. I worked in the mining industry, and one of the things that we had to do at that point, even though we did not call digital twins, but we wanted to make sure that we digitize each and every unit process in the flow program for production line. And we had that, and I understand a little bit of impact on the changes in any of the configurations in that process. So we were doing like the process optimization. So today, this is what is called digital twins, because now you combine it, and the models are now very realistic. So it makes even factory floors to be more easy to maintain and to operate. So yeah, it's
absolutely.
No, thanks, thanks, Gavin. Thanks for that. And thanks,
sure.
Gavin, the chair.
My pleasure. Montserrat, were you going to jump in?
Yeah.
Hello, sorry. Oh, yes.
Yeah,
Go ahead.
Sir, it's early in the morning here, so I'm just trying to catch up with the meeting and see what is going on.
Yeah, which country are you in, Mossad? You're still in the morning. Are you in the US?
Yes.
Okay. All right. Welcome.
All right.
Thank you. We're working towards dinner now in South Africa.
Yeah, I understand. So yeah, I've been trying to catch up with the meeting since yesterday. That is why I had to get up earlier today and see what is going on.
Yeah, great to have you.
Okay.
Thank you, everyone. It looks like we have come to the end of our hour. As Kevin has pointed out with his email, please contact him if you have any further questions. And also, please contact us at the CHPC. I posted the link to the summer school for those who might be interested in that. And if there are any further questions, you know, you can follow up with either of us or any of us at the CHPC too. The program will continue in this Birds of a Feather session on education at 3:15. There we will have a panel that will be dedicated to discussing the issues of online learning, which we've all been experiencing the last 18 months. And so that'll essentially be continuing this series on education in a more broader context than just specifically HPC. So you're welcome to join us at 3:15. I'd like to thank our speaker again, Kevin, for leading this Birds of a Feather session. Very interesting. And thank you all for participating.
Indeed, it was great being with you. Thank you and have a great day.
Thank you, you too.
Bye-bye, and welcome the Girls for Education, Brian. I can see you leading the pack. You guys are nice and early.
We're very eager, yes.
Okay.
Yes, this is the same session. Yeah, thank you. Okay, thank you.